Hey everybody, this is Larry. This is me going over Q4 of the weekly contest 279. Minimum time to remove all cards containing illegal goods. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and how you solve it. This one actually, I took a long time on this one, about 18 minutes or so, I think. To be honest, I thought that this was a little bit easier than I expected in a way. Well, not even that. Just the formula was easier. I guess I should have tried it, and eventually, when I did try it, it was good on the first go. I'm just going over my thought process during the contest. Of course, we'll explain the video, explain the problem. Don't worry about it. But yeah, but I don't know. I think I just got a little bit confused about how to do this one because I thought that it would be more complicated. I was thinking about some sort of binary search and stuff like that, and it took me a long time to kind of think the problem because I was thinking about dividing it into thirds almost, where you have the left side, the right side, and the middle side, and try to figure out how to figure out the boundary. And of course, if you do it that way, it's easy and straightforward, but then it's n squared, right? That's just brute force. So then the question, because n is 10 to the fifth, or 2 times 10 to the fifth, you try to figure out where you want to reduce the time from n squared to at least n log n or n or something like that, right? And in this case, so the way to do it is just to be actually pretty straightforward, and I kind of messed up, to be honest. I feel a little sad that I took so long on this one. But the idea is that just brute force splitting the problem, right? And what I mean by that is that, in this problem, you have kind of two separate problems, right? One is from the left side and one is the right side. And then you have these cards in the middle where you don't know if they should be in the left or the right. So then the idea is that, okay, we brute force switching to the left. So what I mean by that is that, okay, let's say you have some, very long number, right? So then the idea is that we brute force splitting, initially we split it here, then here, then here, then here, and dot, right? And then the idea is that, okay, if we could solve a different variation of this problem, let's put this toward the middle so it's easier to see. If we solve this separation, this variation of this problem, what problem should it be, right? It means that there are two different problems. All the numbers on here should be attribute to the left, and all the numbers here are attribute to the right. And then here it becomes very simple math in a way. It basically is saying, okay, it costs 1 to remove it here. It costs 2 to remove this, dot, 3, 4, 5, 6, 7, 8, 9, and then 10, right? Of course, you can also do it 2 at a time, which is 2, 4, 6, 8, and then 10, right? Okay, so let's pretend that's a 10. And then the idea is that at every space, we take the min, and then the min of the cost that can happen, right? Yeah, and that's basically the idea. And of course, we use a sort of an idea of prefix min. I think strictly speaking, this is dynamic programming. Basically, you can think about it as, okay, let's say we're going from left to right and we only care about left to right. This is dynamic programming in a sense that, and this actually, it doesn't have to be, but you go, okay, how much, what's the cheapest cost to have this prefix? Well, the cheapest cost is going to be 0 because there's no ones, right? And then here, the cheapest cost is going to be 2. Here, the cheapest cost is still 2 because there's none. Here, the cheapest cost is 4. I guess I took a real one, but this is also 4. This is going to be either 6 or 6, so this is 6, right? Here, so you have two choices. Is either the previous 1 plus 2 or the distance from the left, right? Because distance from the left, you just fill it out one at a time. So this is going to be 7. This is going to be 8, and this is going to be 8, 8. And that's basically the idea, right? So that means that you can fill out this left in cost 8. And that's pretty much the idea. And then now you do the same thing from the right, except for you're going in reverse. And once you do that, you can go, okay, so it costs 8 to do on the left, and then some amount on the right. And then, yeah, and then you brute force this division and get the minimal cost. And that's basically the idea behind this problem. I really probably could have done it a little bit faster, but and this is the code that you can see that is pretty clean, I think. Basically, I wrote this function to calculate what we did before. Again, if x is equal to 1, then we add 2, or we set it to the min of I plus 1, meaning the number of spaces from the left, and then we return this prefix array. We do the same thing for suffix. We just kind of, double reverse it. We reverse the input, and then we reverse the output. And then at the very end, you just take the minimal of the sum between the prefix and the suffix, meaning that now you divide it in the middle, and then you take the min of that, and that's pretty much it. This is going to be linear time, linear space. This is linear time, of course, and we do a linear time on the entire array once. So this is linear, but we only call it twice, right? So that's going to be linear, linear, and then linear. And of course, this is linear space because we have two arrays that we return. Cool. That's pretty much all I have for this problem. Let me know what you think. Let me know if it's a little bit confusing. Definitely with these prefix sum problems, it can be very tricky. And this one, I think is, I call it prefix sum, I guess, but it's probably more directly dynamic programming, to be frank. But maybe I didn't call it prefix sum, but I call it the prefix dynamic programming. That's why my naming is as such. So yeah, and as with dynamic programming, it definitely can easily be messy. So yeah, anyway, that's all I have for this one. Let me know what you think, and you could watch me solve it live during the contest next. Okay, cool. People already finished Q4, and I have a 5-minute penalty, so this is sad for me. If this is easy, okay. Binary string s of I is equal to 0. I've called is not containing. Okay. We move a twinkle from the left. We move 0, okay, to the right. From anywhere in the sequence and takes 2. Okay, what is n? N is 10 to the 5th. Why is this C++? Did I do something? I guess I did one problem in C++ at some point, but okay. So here you can remove do, and then yeah, and then that's 5. Okay, this one and this seems like it's doable. It's just brute force in a way. Let's see, why does this keep going to C++? Okay, how do I want to do it though? Is it brute force? Is it greedy? Yeah, because it's not greedy. Because, for example, you can have a case where you have 0, 0, 0, 0, 0, and a lot of ones, and go ... And then in theory, if you do greedy, you may remove 2, 2, 2, 2, 2, 2, 2, but actually it makes more sense to do all these ones and then do all these, right? How do I do this? Is it DP? I mean, it's some sort of greedy, but I can't do in n square is trivial. But how do I do an O of n? And also, what if you have a case like this? Is it better to do prefix or just do this, right? Unclear. Or like here, you would actually go all the way from the left, and it would still be cheaper, even though if you do some greedy, it's going to be wrong. Some idea is that we do the prefix and then you do the suffix. But then how do I do the suffix in a good way? Is it asymptotically? No, I don't think you can binary search on the rest. So let's say we start with everything as 2, right? So we just 2 times everything, and here we go, okay. But if we do them on both ends, it's going to be n squared, that's the problem. Let's say we have a fixed linear thing. How do we do it? How does the scoring look? A couple people already got all of it, and I am way behind because of that 5-minute penalty. It seems like. Actually, I'm 25th, but okay, well, that's a little bit awkward. But that's still a 5-minute penalty, so it's going to be a little bit slow. So I just have to focus on getting this one. How do I do DP? Can I do it? I guess is this shortest path? Can I do this as a shortest path? From left to right. I can do a shortest path because here it's either 2, is it? Okay, so we could put first the left, but how do we do the right? First the left, and then greedy, and then greedy on the other side. Does that really make sense? Let's see, each bit would only be, each island would only be to the left and the right. So at a certain point, you can prove first that bisection. Right? Is that true? Can we get the best answer for a given thing and then divide? Okay, maybe that's the idea. That okay, you have this thing. What is the best answer here? And the best answer here, can I binary search on this answer? Is this okay? What does that mean to binary search on that answer? Okay, let's say we only have 1/2. What does it mean to binary search on this answer? Because it's not a. I mean, we can maybe do a ternary search, but that's tricky. But basically, you have a thing that what is the best answer that I can do? A lot of people are getting this one, so I think I'm going to fall really quickly if I don't get it. Also, a lot of people probably didn't get this silly wrong answer. So, I don't know. So many accepted already, but I don't really think I know this one. Can I figure out half? If I could figure out half, can I binary search? If I go, let's say I take a mid, right? And I get a cost. What does that mean? I can definitely do ternary search, but that feels yet icky. Can I do ternary search? Yeah, because it is a minimization problem. 2 times 10 to the 5th. It's probably going to be okay. Actually, I don't know. Maybe not. Maybe even binary search is a little bit icky. I guess that's maybe the idea. Is this sort of dynamic programming-y things, right? And the idea is that, okay. Okay, let's have something like that. And then, so how do I want to write this out? Let's just figure out 1/2 for now. Okay, so then now, okay, I think I have an idea. Prefix of I. Okay. Okay, right. So that's the cost of just doing it naively, and then, yeah. So that this is just 2, 4, 6, 6, 8, and then the DP would be maybe, I don't know if this is right. And this is very slow. given that this is just one for loop. Okay. Is that right? 2, 4. Is that true that there's none of these is minimal? I guess this input is just awkward as well. Because this would be okay. So let's say I have some input that's pending is server is so slow. Okay, so 1, 2, 3, 4, 5, 6. So that's awkward. What am I doing wrong? This is not right. This is no. This should be. Oh, because these are zeros. That's why. So it should be maybe something like something like that, maybe. I think that's the function that I want. And as soon as we can see stuff, hopefully that'll be better. Okay, so I think that's good. And then the question is, okay. Okay, and then now best is equal to min best of prefix of I plus suffix of I plus 1. I don't know if this is quite right, but maybe. Set maybe none type because I don't return because I'm a silly goose. That Q2 though, I'm so tilted still. N is not defined. Don't I define it? Oh, I guess so. And it takes like too long to even just want. The server was so fast earlier. I don't know what happened. Like it takes like 10 seconds to me to see this, so it's a little bit sad. 3015. But that's not right. Why is this giving me 0? Tell me why. Okay, well. Unknown error, thank you. Server's just yikes. Me is yikes. Okay, so this is doing 0, 0. Why? Because I am having an off by 1 somewhere. 0, 0, 0. Basically, this is saying this cost will cost 2. So that's this cell, and I compare this cell with this cell when I should compare it with this one because it is offset by 1. So it is suffix minus 1. That's really awkward, but okay. I think that's right though, or at least more right. Except for not, I guess. Maybe this is actually now more. I think it's just this. Because I forgot that when I shift, you have 0, 5, 2, and 6. I actually don't know if 6 is right. Yeah, okay, because now this is going to that one, but that one we want. Yeah, okay, I see. I think this is more right. I don't know. Well, this is an idea. I don't know if it is the right idea. And just wanting the code takes so long. All right, we'll see if this is good. This 5 minutes still annoys me. These 5 minutes. What a silly 5 minutes. I mean, this is linear, so I don't think it'll time out. So, okay, cool. Yeah. Thanks for watching. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about today's problem. I'll see you later. Stay good, stay healthy, to good mental health, and take care. Bye-bye.